QR code has these slides on them. There's a lot to follow along. There's a lot of content. There's a GitHub repository as well. So I'm going to give you guys a second to find that if you are interested in following along actively. If not, obviously, slides and tools are always going to be available. Well, as long as Google's up, who knows? So hi, my name is Sara Golemon. We're going to talk about extending PHP, which is basically taking the core runtime of the PHP language and adding in basic functions that can do things that you can't necessarily do in PHP. Things like call into external C libraries and even link to other languages like Rust or Go or whatever the heck you want to do with it. We're not going to go super deep because we only have about an hour, but I'm going to try to cover as much as I can. Hopefully you've had the QR code by now. If not, it will be on the last slide as well. So obligatory about me, I have been doing PHP for a very long time. This is the only photo I could find from 1998. I worked for the government. They had a dress code. Don't judge me. I much prefer modern dress codes. So yeah, fun fact, I'm actually about to move to Europe. So you'll probably see more of me in the future. It's a lot easier when you don't have to cross an ocean. There we go. So yeah, quick overview of what we're going to cover. We're just going to do some very basic extensions that do link in external libraries. This is 90% of what goes into a PHP extension. It's just taking some existing bit of functionality and exposing it to script where you can actually use it from a user space. So MySQL does this. Drawing a blank on other extensions. Obviously, there's other extensions, SQLite, Oracle, things like that. So we are going to look at the GMP extension. It's a very simple library to call into. It's very easy to define what it does. It has no external dependencies on the network, so it's a really easy example to work from. I keep hitting right instead of down, and that doesn't work well. So in the base, I skipped slides. There we go. This repository has got tags all over it to step through us one at a time. The first tag is the bare minimum skeleton extension, which does nothing at all except load itself into memory and says, hi, I'm an extension. So you can check that out with that tag. Once you do, you will have two files. Yeah, two files in your repository. You'll have a, this does not match this. Why does it not match? Oh, because Keynote's being clever. I'm sorry if I've had the wrong slides up. No, it's just lagging. That's super weird. Technical difficulties. All right, so you'll have two files in your repository. You'll have a config m4. The only line that's really important here is this PHP new extension. This is just saying like, hi build system, I have some files I would like you to compile. Please do whatever magic you need to do to make that happen. I have included also this arg enable flag. This comes out in configure output. So when you're on /configure, like you do with lots of programs, there will be a line that explicitly says -- enable my GMP, or it'll say disable because it's enabled by default. By convention, we use enable disable for extensions that do not have external dependencies on them, like external libraries, and with for ones that do. Right now, we don't have the external dependencies, so we're calling it enable. But the only line you really need for most third-party extensions is this new extension until you've done something more interesting. Why are you lagging? Should there be this much lag in the screen? If I go again, what happens? That's so weird. Okay, well, the other file you'll have is a C file. The only important thing in here is this module entry component that we have. Everything that your extension actually does and exports to PHP's runtime is going to be somewhere in here or something that's called off of this. Most of these are callbacks to additional functions that you're going to define later on. And we'll talk about what these minit, shutdown, r shutdown functions mean in a moment. But the only important thing we have here is this little red mygmp that you can see right here. And I'm zooming because I chose a terrible color for this, but it does say just a single quote, a double quoted string mygmp. All right, now it's moving. Okay, cool. Once we have those two files, and that's all we need, it's just a matter of building the extension. For building any PHP third-party extension, you're just going to run these three commands. phpeyes, which says take that config m4 file, which is kind of like a composer JSON for extensions, and make a configure script that knows how to decide how to build this extension. Run configure, we don't have to explicitly say enable mygmp because it knows this is the only extension we have to work with. So obviously you're going to want to enable it. Whole bunch of output as it looks for local things about the build environment, and then just make. Actually compile the thing. At the end of all that, it's going to say, great, your build's complete. Don't forget to test it. I'm not going to write any tests. But you can load that up with the PHP CLI. We've got -d means define an INI setting. We're going to define the setting extension equals modules/mygmp.so. That's where the compiled extension got put when it was built. And we can use --re to do extension reflection. It's the entire reflection API is accessible from the command line, and we're going to say, tell us all about the mygmp extension, and it's going to say, yeah, I have really nothing to tell you about the mygmp extension because it doesn't do anything, does it? Exciting. Unzoom, thank you. So now that we actually have an extension that just exists, it's time to make it do something useful. And the first thing we're going to want to do is grab that external GMP library and link it into our actual bundle. Linking in a compiled sense just means grab somebody else's SO and put it into the same process space as what we're using. Come on. Come on. Interesting. Okay. First thing we're going to do is we're going to update that config M4 file because we need to do some more things now. Now we need to tell the build system where to find that external library and what to do with it. Package check modules, all we actually need today for modern extensions. For some of the older libraries, they don't have package configure scripts. You're going to have to go out and manually look for the headers. Look through the PHP source tree if you run into one of those, but usually package config it actually exists properly on modern systems. The rest is boilerplate. Just go ahead and run with it. You will notice I've changed arg enable to arg with because, again, by convention, if we have external dependencies on external libraries, we will use just the with word instead of the enable word. It doesn't really matter. I've gone and made that completely backwards. Okay. Come on, man. Be cool. There. So now that we've got the library loaded into our module, we actually have to call into it and do things. So we take this module structure that I talked about earlier, and we're going to replace some of these nulls that were in there saying to do nothing. The null for info, and I've got a typo on this slide, sorry. Under where it says info is actual minfo. We're going to say call the callback defined as php minfo mygmp, which is defined just above there. And this is literally just outputting key value contents describing the extension. So by default, we always have a, not by default, but by convention, we always have a line in here. If I can scroll slower. I can't actually see my mouse, which is super helpful. Let's do this. There we go. All right. So I'm going to create a table. This is essentially a table tag with some TRs, TDs, HTML kind of stuff. Left column, mygmp support is enabled. The loaded libmygmp version is this global variable that GMP actually exports. So we're just providing some information about our extension. We're not doing anything useful. We've also replaced the minit and mshutdown functions. These are the module init and module shutdowns. They're called once when PHP is first loaded up, and then when PHP is actually shut down, so you can do cleanup of things that need to be deallocated. For init, we're going to initialize the random number generator so that it's not just going off of garbage memory, and then we're going to clear all the information from that random number generator at the end. So the minit and mshutdowns all return either success or failure, and minfo is just a void function. And we can call that, again, after we've rebuilt it. Here's our PHP info output. Who knew that --ri actually existed, by the way, on the command line? Well, now you know. You could call ri standard or ri array and get just that module's outputs. Pretty handle. Oops. And come down. So those minutes Rinits, all of those, these are part of the life cycle management of PHP. Like I said, minit is called exactly once when the interpreter is first loaded up, like when you start FPM or Mod Apache if you're old school. It goes through the minits on all the extensions so they can do all their setups, and then shutdown is the very end of the process. Ginit and gshutdown, that's G for globals, this is for thread initialization. So if you're in a multi-threaded environment like Apache 2 Worker, do we have any other multi-threaded environments? That will call it anytime a new thread is spun up to handle requests, and then gshutdown when that thread is actually destroyed. So it's less often than per request, but it's a lot more often than module. Per request being R. Request init, request shutdown. This is the equivalent of auto prepend file, auto append file. So anything you need your extension to do all the time, like the sessions extension, if you have auto save enabled, that's handled through an R shutdown call. When the request is done, it writes the session to disk. So next up, we're going to actually do something useful with our extension. We're going to add some functions. We're going to take some values. We're going to return some values. And we're going to try to understand why Keynote is lagging on outputting to the external display. I don't think it's my laptop because I'm just mirroring. Sure, why not? There, that's the right page. Okay, so defining a function means we're going to have to introduce a brand new file. This brand new file is going to be mygmp.stub.php. This was just introduced, what, PHP 8, right? Or 7.2, something like that? This allows us to define what the signatures for our functions look like by writing them actually in PHP. So this is just PHP code, but we're not putting implementation in here. We're just reusing the syntax to define what our input parameters and output parameters are like. Useful because we now have, static typing and strict typing is what I was looking for. Once you've defined that, you can add in this x_functions variable into the module entry. This is going to be a magic locally global variable, which has all of the definitions from your functions that are built through code generation. And then we actually implement the function by just saying PHP function, name of the function, and since we're not accepting or returning parameters at this point, we can just do stuff immediately. And in this case, PHP printf is literally just the echo statement. We want to output something, so there you are. Now a note, the build system isn't going to automatically look for your stub file because you don't always necessarily have one. So the first time that you add this stub file, you do need to explicitly say make your extension _arginfo.h. That will compile it'll generate a source code file called, in this case, mygmp arginfo.h. And then we can include that from our source file to actually get that generated code. And you can read this file. It's a whole bunch of auto-generated nonsense, but it's interesting enough. And then we can rebuild. And now we have a function. -r allows us to eval simple code snippets. We call mygmp version. There's our output. Job done. Go home. Okay. I'm just going to preemptively double tap down, apparently. So now that we've added one function, let's add another. This time, instead of outputting directly, because outputting from a function call is a little bit pathological, we're going to instead create a function called mygmp get version, returns a string, and we're going to use that same global variable, that gmp version variable that's exported by libgmp, and we're going to use this return string macro. Have I written anything that looks like actually hard C yet? No, I've been writing macros because PHP provides a ridiculous abundance of macros to make writing extensions kind of take all of the hard edges off, and more importantly, be consistent between versions. Everything I've written so far, except for the stub file technically, would work on PHP 4 just fine and continue to work into PHP 8. There's a lot of intercompatibility between releases of PHP. So I had return string there. Obviously what it does, we can return other variable types, nulls, bools, trues and falses explicitly, everything that's up there. It gets a little weird in the lower half of this list where we get into return R, return res, return obj. These are for the more complex non-scalar types. These require you to build up larger subordinate structures, because obviously you can't just express an array with using square brackets and numbers, right? That would be silly. But all these macros should be fairly easy to read if you're looking at somebody else's code, and hopefully fairly easy to write. Okay, so for every return macro that exists, there is an equivalent retval macro. The only difference between them is that while return actually will exit the function immediately, retval will just say, hey, save this return value for later when I actually leave the function, but I got some work to do first. I need to clean something up. I need to do whatever I need to do. And it is literally just calling retval x return is all the return macro does. And similarly, we have zval macros. These will take a place to put that information. By default, for the retval and return macros, they go into a magic local variable called return value. This is passed into the signature that's hidden inside this PHP function macro. And when you say return string, it's really saying, I've got a string, wrap it up into the things that need to be wrapped up into, and drop it into this return value variable. The type on that is zval. We will look at that later on. But for now, that's all you really need to know there. So we're going to do something more interesting now. We're going to make a function that actually takes advantage of the library instead of just telling you what version is loaded. And we're going to take in some arguments, we're going to do something with them, and we're going to return it. This is the first real function we've gotten to. So we've got mygmp add. Again, you throw something into the stub file to tell you what types you take, what you return. Again, this is just PHP code. Any PHP developers in here? Good, okay. Zen parse parameters is one of the ways, there are multiple ways, but is probably, in my opinion, the easiest way to actually pull arguments off of the call stack. And I've got in red there, it's a double quoted string, just says capital P, capital P. These are technically path strings. The difference between an S specifier and a P specifier is that P doesn't allow null bytes. So I try to use those whenever possible because null bytes can get really weird in C. But they're basically saying strings. So I say, I have got a function that accepts two strings, put the first one into the next arg, which is arg1, put the second one to the next arg, which is arg2. The ampersand works in C a lot like the way it works in PHP. The mechanics are different, but it basically is saying reference to that variable. So pass arg1 and arg2 by reference into Zen parse parameters, go get me some strings, drop them in. The rest of this is all libgmp stuff. It just says initialize some numbers to hold this information, parse them as base 10 strings, add them together, and then serialize that result back out into a string, again, in base 10. Drop that into this zster return value, and then actually return that at the end of the function. And we can, again, run this with maximum 64-bit integers that PHP allows, add them together, we get the correct result that is not normally expressible in a long integer. So that specifier string that I mentioned with the capital P's, these are most of the other format specifiers. There are a collection of others that are used in really weird esoteric cases. We don't need to cover them. Most of them are going to be pretty obvious. B for bool, L for long, D for double. Long being a fancy word for integer, double being a fancy word for float, however you want to choose to say that. As I mentioned, there's a subtle difference between S and P because P does not allow null bytes. Very useful if you're calling a C API that doesn't take a length on it. The lowercase s versus the capital S, that is the difference between PHP 5 and PHP 7. In 5, we always pass strings as separate pointer and length components. In 7, we developed this Zen string type, which is a composite of that. It holds onto the hash of the string. It's just more memory efficient and time efficient and helps the engine run better. So you can still use the lowercase versions, but the uppercase versions are generally preferred. Again, with a more complex type, we're going to have to get into those in a minute. Oh, and you've got some modifiers here. So pipe delimits optional args. Anything up to the pipe is a required arg. Anything after the pipe is optional. We're not going to go into Bang and Solidus here because those are more complex topics. There we go. I mentioned the Zen string. So this, as you can see, it has the actual car star pointer, or actually car array pointer in this case, and a size t that indicates the length of the string. We also have this h, that is a pre-computed hash. This is valuable because when you're looking up things in PHP arrays, They're stored in a hash table, which I'll send somebody a link if you're interested in how hash tables work, but having digests of the contents of the string makes the lookup much, much faster. And this just saves it. We also have this GC, which is our garbage collection or reference counting structure. So if you have the same string appearing multiple places in your script, that's only going to be stored once. And it's going to say, well, we've got a reference there, 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 and there. And now it's been stored in this other variable. So we're just going to make another reference to it there. And we only have one real copy of the string contents rather than having 5 or 6 or 1,000 different copies of the string contents. There's APIs for this in zend_string.h. You can find them all, but these are sort of the cores of them. Allocate some memory, write into it, use it around, free it if you're done with it, and it'll keep track of all the ref counting for you. And we can get to the, I should actually point, we can get to the underlying pointers and lengths through these zstrlen and zstr values macros as well. So, quick pause for questions, because I know I talk fast, and I know that there's a lot to absorb, and I want to cover it if I've missed anything, but nobody's raising their hands. I'll repeat the question, just.
Okay. Is it the same for FPM?
I'll repeat his question. Yeah, so you're asking, is it the same for FPM? Like, is there any difference depending on how PHP is used? The short answer is no. There's a longer answer about thread safety, but since we generally tend to run in non-threaded environments, I can even kind of sidestep that question a little bit. But yeah, the short answer is no. We call those SAPIs, Server Application Program Interface. And they were abstracted super early on. Basically for Apache is when they got abstracted. So if you're developing something for CLI or Apache or Nginx or FPM or whatever, it looks the same to you as an extension developer. The only exception to that is if you are explicitly doing something for your web server and you need to reach into their process space, then things get a little weird, but that's very edge casey.
Yeah, mostly I ask about like shared memory, like between workers in FPM. So it's the same. I just use the request init or the ginit if I want to have something between workers, right?
If you want to have something between, requests on the same process, that'll happen in mInit. You'll allocate some shared memory segment for that. If you want to have shared content within a single thread, which persistent connections tend to be per thread so that they can manage their orchestration between each other, that'll usually happen in ginit, gshutdown is where you'll deal with those. And then rinit, rshutdown, that's just specific to one request. There's nothing you're doing outside of that.
Okay, so basically extension for PHP is also extension in FPM.
Yes, yeah. All right, so we'll move on. So arrays are going to be the first of the more complex types. Everything else before that is either an actual scalar or a string, which you can often think of as a scalar just because of the way they get represented. But arrays, we have a little more work to do. So I'm going to make a very simple function that just gives you a whole bunch of random integers straight out of libgmp, arbitrary precision, arbitrary number of them. And so naturally, I'm going to ask for how many numbers do you want and how big should they be? How big they should be? Well, we can default that to 64 bits. So let's make this an optional arg. So we have L pipe L as our input set. The first one, the count, that's required. And then the bits is optional because it comes after the pipe. And then just like you would write in PHP, we're going to initialize an empty array with array init return value. There again, that magic variable that represents something that is accessible within the function implementation. And then we're just going to go through the count. And I'm using kind of a C developer hack where you count down from having a number and you get to 0. You could also think of this as just for I equals 0, let I less than count, but I tend to write things this way. We're going to ask GMP for a number, and we're going to put that into the array with, in this case, add next index long. So this is like saying $ret, open close square brackets equals GMP, give me a number. And look, we have a list of numbers, 2 numbers in the 64-bit range, and we could get that as big as we want. Anyone see a really obvious bug in this yet? Yeah, we haven't actually done any error checking, so I do want to mention, come on, how you would actually catch things like that. So boundary checking Do we want to do a negative number of integers? It's probably not the most useful thing. It will, because C, wrap around after about 16 sextillion, but we'll probably run out of memory by then. So let's at least say it's not negative. Now you've constrained yourself to 8 sextillion. We could put an upper bound on this, but that's just adding more logic to it. The way we raise our errors is we're going to say, in this case, we're going to say PHP error, the error level, E warning, and then just a message in this case that says invalid number of random numbers. And we're just going to return false as our return type. When we put up the prototype for this, the return type was string pipe false, because we're using kind of the old PHP convention of returning false on error and then returning some other type on success. That's a bad habit to get into, but I'm showing it anyway because you can do it. In practice, you should probably be throwing exceptions instead, but I didn't want to overcomplicate this. So this is just kind of the basics. You can look through the PHP source and find examples of Zen throw exception on how to do this, or we can hallway track it. Same thing with the bit size. Less than 1 bits doesn't make sense. Greater than, I've actually limited it to 64-bit here as our maximum size because we are putting these in as PHP integers into the return array, and I don't want them overflowing. And then same code for actual output. So basic error handling, very basic. As we're building up these arrays, the array creation API, I think is pretty straightforward. Array in it, that just makes a brand new array. $r equals array or open square, close square brackets. And then adding to them have got their own set of macros. So it's essentially add underscore key type, underscore value type, and then some set of arguments that are appropriate to those key and value types. So we used add index long, so that would have no key type for the parameters, and it would have a Zen long for the value. Pretty straightforward, I hope. So I'm not going to go into any more on that. Now, what if we wanted to access the contents of an array? Instead of writing to an array, we're going to actually read from it. So this time, instead of having an add function that takes 2 separate numbers, we're going to have a single arg, and that argument is going to be an array, and that array is going to have the keys A and B's values are going to be the things we're adding together. This is a terrible API, but if that's what you want to do, have a nice time about it. So we're going to use Zen symtable stir find to pull values out of the array. The keys we're looking for are A and B. Because I'm using stir, I can specify the string and its length separately. There is a version that takes a Zen string instead, but I thought this would be a little easier to demonstrate. We're going to make sure that the number 1 exist. If they don't exist in the array, we'll get nulls out. And number 2, that they're of an expected type. And in this case, I'm looking specifically for strings on the output types. Once we have that, we can access them through those z underscore whatever macros to pull them out, and we can drop them into return value. This do mygmp add, this is effectively what we had in the mygmp add function, but I abstracted out the common libgmp work to do the functionality. When you look in your checkout, you'll see the implementation of this. It just wasn't worth actually showing. So we have a number of ways to look at arrays. I showed you Zen symtable stir find as kind of the easiest example. Zen symtable find is the same thing, but it uses a Zen string instead of separate pointers and lengths. And of course, you have Zen index find for numerically indexed arrays. Pretty straightforward. Come on. Thank you, Apple. You saw a couple of these macros already, these z underscore whatever underscore p macros. These are yet another way for dealing with PHP's notion of a variant type, something that can represent any kind of user space value. So this variant type is called a zval. It is a deep nested struct containing all of the possible ways of representing information. So there's integers in there, there's char star pointers in there, there's hash table pointers in there. There's all the things that could be in an array are available. They overlap each other in a memory, and then there's one little byte that says what kind it is. You access these through these macros. Z-type P in particular is going to tell you what type it is, and then you can decide which of the other macros like Z-lval, Z-stirval, Z-resval to actually use. The P has to do with the level of indirection, and this is getting into scary C pointer stuff, But the bottom line is a variable in C can either be the data directly, or it can be a pointer to an address where the data actually lives, or even a pointer to an address that's a pointer to an address where the actual data lives. There are pointers in PHP that go all the way out to 4 stars. They are terrifying, don't touch them. But most of the time, when you're dealing with the output, especially from an array, you're going to have a zval star. That's going to be a single level of indirection, and you use a single underscore p because it's a single pointer. In PHP 5 and earlier, you would see pp a lot more often, but because we changed the way variables are stored in PHP, you don't see the double pointer quite as often. You more often see direct zvals, which have no p's at all. How many times can I say p? Come on. There you go. All right. So let's look at iterating through arrays, because arrays are, arrays with specific keys in them are great for packaging up big blocks of data like option blocks, but more often we're working with lists of data, 0 through n copies of a piece of data. The very simplest way to do this is something that was only introduced in PHP 7, I want to say, the C4each API, Jarek, maybe? I think it was PHP 7. And that is the Zend hash for each val, Zend hash for each end. This allows you to write something that looks essentially just like a for each function in PHP. You pass it in an array, and you have another parameter for the actual value that you're getting on each iteration. And this, again, will be a zval star, which is what we have declared up at the top. There are different versions of this. There's for each key val. There's for each reverse key val, and a few others. But this is probably, this one and key val are the most common that you're going to hit. So once we've got our zval star, we can call zval get string. This is going to check your type, coerce if necessary, and give you something out that looks like a string. So now instead of having to say, well, is it is string? Is it is long? Is it is double? You can just say, is this expressible as a string? If so, give me a string. Usual stuff that we had in other implementations, we're going to make a libgmp value out of it. We're going to parse it in. We're going to add it together with a cumulative total, and then we're going to clean up after ourselves, and then we're going to continue the loop and serialize out as we've already done a couple of times before. So that's one of the array iteration APIs. Oh yeah, I did write versions here. Okay, so that version of array iteration only exists from PHP 7 onward. If for some insane reason you need your extension to work on PHP 5, there are other APIs that existed back then. Zend hash apply will call a separate function to handle the iteration of each particular call. It's not bad, it's fine. It's just a different way of organizing your code. And then Zend hash internal pointer reset ex and family are an extremely manual way of working with arrays. It's the equivalent of calling for list key value equals each array. Anyone ever use that style of array iteration in PHP anymore? Good, it's a terrible version. It is, but it exists, it still works, you can still use it, you can write an extension of PHP 4 and it will still compile and it will still run because fanatical dedication to backwards compatibility. So, oops, that is the one animation that you're getting all day. And strings, so we have the more simple, more common C API look of strings, which is a char star pointer and a integer length or size t more precisely. We have the Zend strings, which were introduced with PHP 7 that encapsulates those into single variables, adds reference count, well, better reference counting, and ways to just let the engine work better. We have the various string allocation and accessing APIs for more information. You've got zenstring.h where you can see all the APIs. They're not well documented because who has time to write documentation? But hopefully most of them are straightforward enough that you can guess what they do. Arrays, come on. We have a similar set of common APIs for initializing arrays, iterating through them, adding to them, enumerating them, finding out how there's an equivalent of count. Zendhash.h has got all of the APIs, and there are a great many of them because we are still compatible with a lot of PHP 5 extensions as well. I have, in this bottom right corner, Nope. Jesus. That was not how you were supposed to do that. God damn it. There we are. That's what I was looking for. This is a header-only file that I've got in my GitHub here. It's under sgolemon/phpArray API. This is a version-agnostic wrapper around the PHP array functions that does a lot of the type conversion automatically for you. Very handy, I think. It's taken very little attention because PHP is stable, but it's there if you want it. Come on, now we're jumping too fast. Okay, so that was a recap of what we've done so far. Now we're going to get into objects, unless somebody has a question before we go on. Nope, cool, awesome. Yeah, objects, just like arrays, they are more complex structures. You actually have to do a little more work to define them, to get them to do what you want to do. We're going to go through 3 more checkouts here as we explore them. But we have this wonderful stub file. So let's just declare a class. We got a class called mygmp, and it has a constructor. That's almost all the work you have to do to actually define your class. This again is a sort of a catch-up to where our stub file is now. If it doesn't look like this, then I've spoken too fast and I've confused you about something. But once we've added that, come on, there you go. We are going to add one more line to our minute function. We're going to say register internal class CE. And this is, again, kind of a magic variable that just exists in the arg info that becomes available automatically. It gets a little weirder when you have multiple class definitions, but this one's available to you. You drop it into a locally defined pointer that includes the definition for that class. And then writing a constructor is just like writing a function of anything other kind, except now you have a magic this variable in it. However, this is not going to be very useful until you've done something more interesting with the class. And in this case, we are going to add custom data storage in a hidden little compartment off of the class. So normally when you have a class in PHP, you define properties, right? Maybe you have a private property, a protected property. Well, there's not really a PHP type for storing raw pointers. I mean, there is, but for the sake of argument, no. If you need something that restores a reference to, in this case, a libgmp arbitrary precision number, you need to allocate just a little extra memory to the side to store that. And that's what this custom object allocation is for. So we're going to extend minute further, and we're going to say, okay, that class definition that you have, let's define our own create object method. This is going to be the actual memory allocation for your object. And let's define some alternate handlers for how that object is going to initialize itself. This is mostly boilerplate. Follow along what I have here, and you're not going to go too wrong, but I will point out the structure of the GMP object. We put that extra memory behind the official Zend object implementation. This is important because when the engine looks for your object, it only wants to see its standard object definition. It doesn't care about your private data. So we stick it behind the pointer, and then we very cheekily adjust our pointer back whenever we need to access the stuff that we're interested in. And these are the implementations for the clone and create. They are very bog standard. They are very do it by the numbers. The only thing I've really added in here is the mpz init and the mpz set to either clear out copy the value over to a new object being cloned or initialize a brand new object when we're setting it initially. And then mpz clear to get rid of it. Why is this like this? Okay, we can finally get to a constructor. This constructor, we're going to set up to take one optional mixed variable. So this can be of any type. I think in the prototype, I actually specified it as string enter float. Yes, it was string enter float right there. And depending on what type we actually get out of it, we're going to call the appropriate libgmp function to parse the number correctly. The important part here, though, is this first line where we say mygmp object equals mygmp from Zend object zobjp get this. This is grabbing $this, and it's dereferencing it all the way back to that structure that we created in the previous slide up here, and it's pointing right at this mygmp object structure. So we can take that pointer and dereference it down to value and get our GMP information out of that. God damn it. There. So now that we've done that, we've built an object, we've called its constructor, we are doing something useful with it. Now we can actually have some fun. And the last bit of this presentation, before I run out of time, is just going to be some basic methods on that function. So pretty straightforward, hopefully at this point. ToString acts just the same way it does in PHP land. We're not going to take any arguments. We're just going to return a string. That string is going to be a serialization, and I have abstracted that out to a helper function. We can pass in a libgmp value, arbitrary base, get it out. For the debug info method, I'm giving us the binary, octal, decimal, and hexadecimal versions in debug info, just in case you need it in whatever form. And then add, sub, mul, and div are all binary operations, so we can just take two values in commonly. These values can be either other instances of a mygmp PHP object, or they can be raw strings, ints, floats, whatever, and we'll upconvert them, do the operation, serialize the output back, give you your return, nothing but net. But now we're returning actual mygmp instances, so we don't have to reparse them if we keep using them over and over again. And that, with, gosh darn it, a couple of seconds to spare, is as much as I've got. So if there are more questions, great. If not, I got a QR code, goes back to the slides. You can go through this at your own pace. Reach out to me on Mastodon if you have questions. My PHP stuff is at the first one, so I'd encourage you to go there if it's about this talk or anything PHP in general. I have absolutely unhinged rants on Fosstodon, opinions on a great many things. Some of them are actual software. You can get the slides, you can get the code off of GitHub. I've also got a How PHP Ticks if you're interested in sort of the mechanics of how some of these engine components really work under the hood. You want to go a little deeper. And Blue Sky technically exists, but it's a billionaire's walled garden, so forget about it.